Okay, welcome to part 2 of stoichiometry, calculating masses from a balanced equation. In part 1, we saw that using this equation, n equals m over mr, that if you start with 3 grams of ethane, you make 8.8 grams of CO2. Now let's see how many grams of water and oxygen we make or need in each case. So in the previous video, we found that we have 0.1 moles of ethane. And to find out how much water we need to look at the ratio, which is 1 to 3. For every 1 mole of ethane, we make 3 moles of water. So we do not have 0.1 moles of water, but 3 times that much, so 0.3 moles. Now, using the equation to find mass, we do mass is n times mr. Moles, we just explained, we have 0.3 moles of water, and the molar mass of water is 18 grams per mole. To do that, you need to use the values on the periodic table. Oxygen weighs 16, and each hydrogen weighs 1. So if you do that calculation, you end up with 5.4 grams of water. Scroll back up. So these are our two products. 8.8 grams of CO2 and 5.4 grams of water. Now again, there's a discrepancy here because we only have 3 grams of reactants and 14.2 grams of products. So let's see how much oxygen we actually need to get this reaction to completion. Now again, we need to do a ratio. For every 1 ethane, there's 3.5 oxygens. So we don't have 0.1 mole of oxygen. We need to multiply that by 3.5. Okay, and that will tell us the moles of oxygen we need to reach complete reaction. Of course, usually there's an excess of oxygen, but we're going to take a simple case here. So we have 0.35 moles of oxygen. To find that in mass, again, we use this equation, moles times mr. So 0.35 moles times the molar mass of oxygen, which is, each oxygen is 16, times 2, which is 32 grams per mole. And that gives us 11.2 grams of oxygen necessary. Now, if we scroll back up, we see that now it does make sense that we are not creating mass. The mass on both sides of the equation is equal. We have the mass up on the left-hand side, we have 14.2 grams, and on the right-hand side is 14.2 grams. So this follows the law of conservation of mass, and that you cannot create or destroy atoms. The same atoms that you have on the left-hand side appear on the right-hand side. Okay, so when you're solving these questions, usually you do not have to calculate the mass of every single reactant or product. You might be given only the mass of one reactant and you find the mass of one product. And don't worry if there is an increase in mass, because that is accounted for from the missing reactant and product, as we have proved in this question. Okay, thank you for listening, and join our latest videos with more on stoichiometry.